from the huge collisions between galaxies.
Dr. Schweitzer of the Carnegie Institution is observing the development of starbursts, a multitude of stars explosively created through collisions between galaxies. In order to capture distant galaxies with greater clarity, he visits astronomical observatories around the world, such as Cerro Tololo, Las Campanas, and Kitt Peak, to conduct his research. "400 photographs of the spectacle of galactic collisions spanning more than 20 years are preserved here. Let's have a look at Dr. Schweitzer's best shot of the lot. This is a photograph of colliding galaxies called the antennae galaxies. The antennae galaxies are 63 million light-years distant from Earth. It is thought that its odd shape, reminiscent of insect antennae, is due to the enormous impact of the two galaxies. Can the collision of galaxies really result in this weird shape? Using a supercomputer, Dr. Joshua Barnes of the University of Hawaii created this simulated image of galaxies colliding with each other. 1 second is the equivalent of 60 million light years. This was the first time that the process of galaxies colliding to produce the oddly shaped antennae galaxies had been explained by an image. Ultimately, it is expected to come together as one galaxy. Let us observe in some detail just what occurs in the interior of the antennae galaxies when they collide with each other. Dr. Schweitzer points the Hubble Space Telescope toward the antennae galaxies 63 million light-years away. This is the Space Telescope Science Institute, located in a suburb of the U.S. capital, Washington, D.C. All of the observation instructions for the Hubble are sent from here. The photographed images from the telescope are sent here first.
In an ongoing starburst, why should the clusters be a relatively narrow sequence?
Together with his co-researcher, Dr. Whitmore, Dr. Schweitzer processes the photographed images of the antennae galaxies using a computer.
Here, like you said, dust. And then I make these 6 plots where I do a color magnitude diagram. That's the second image. So the fact that they're in both images is the useful thing. Yep. How about
This is an unprocessed image as it was when first sent here. Because the Hubble Space Telescope soars outside the atmosphere, high-energy particles flying about in outer space collide with the camera. As a result, there are numerous scratches on the image.
With or without hot pixels? Or?
So, by matching up several scratched images of the same celestial body, the scratched sections are gradually removed.
Oh, maybe you can. So this is the one that does have them. For example, so here are the hot pixels.
This is a close-up image of the interior of the antennae galaxies that resulted from computer processing spanning a 2.5-month period. The interior of the antennae galaxies that were invisible with large telescopes on the ground is clearly reproduced. Previously hidden from us was an image scattered with newly formed blue stars.
In the antennae, the starburst produces thousands of star clusters, from very small clusters that may have only 10 to 20 stars, up to the richest star clusters, which are these globular clusters with up to 1 million stars. And in addition, the stars in star clusters may be only about 20% of all the young stars that are formed. And 4 times more stars are formed just as individual stars. So we are talking of many, probably hundreds of millions of stars that are being formed.
Here, through the giant collision between galaxies, clouds of dust and gas violently smash into each other, and simultaneously, thousands of star clusters and hundreds of millions of stars are created. And among these, without a doubt, many stars are born that closely resemble our own sun.
Scientists predict that the development of starbursts, where many stars are created at once through the giant collision of galaxies, could occur with our galaxy too. Next, let's take the space-time elevator and look at a starburst about to occur with our galaxy.
This is our galaxy. The galaxy does not exist alone in isolation. This is part of a group of several dozen galaxies called a local group. The radius of the local group is 3 million light-years, and the most prominent in it are our own galaxy and the Andromeda Galaxy. We know that this Andromeda Galaxy is approaching our galaxy at the furious speed of 500,000 kilometers per hour. The possibility exists that in 5 billion years, the Andromeda Galaxy and our galaxy will collide with each other. Let's advance the hands on our clock into the future and look at the world 5 billion years from now. The Andromeda Galaxy slams into our galaxy 5 billion years from now. The clumps of gas and dust contained in each galaxy collide with each other here and there, and blue stars start forming explosively. This is the beginning of a starburst. In our galaxy, too, the scene of thousands of star clusters and hundreds of millions of stars being born one after the other appears before our very eyes. Today, the Andromeda Galaxy can be dimly seen in the northern sky, even with the naked eye. It is a huge mass containing 400 billion stars. In another 5 billion years, however, it is thought that it will collide with our galaxy and become the stage for starbursts as we saw with the antennae galaxies.